we're going to look at the Lasa in Unit 5, which talks about the Hamilton method and the appropriation. So what we're going to do is we're going to briefly go through each step using the smaller data set of state 1, state 2, and the number of seats. So I've changed it from what's actually happening in the Lasa itself. So if we look at the first question, it says, use the Hamilton method of apportionment to determine the number of seats each state should receive. So the Hamilton method says not everybody should get equal representation. So I can't have 10 and 10. So what it does is it asks you to calculate D. And I calculate D by taking my total population and dividing it by the number of seats I have available. So in the Lasa, you're going to take all 10 states and add them together. In this case, I only have 250 plus 100, which is 350. So if you were working the Lasa, you would add all 10 of those states up. So for this problem, I have 350 divided by 20, and that's going to give me my value for D. So if you remember, you can use the Web 2.0 calculator to do those simple calculations. And I get 17.5. So this D value is important because I'm going to use it in my appropriation. So to find the number of representatives that each state gets, you're going to take the population of the state. So state 1 would be 250. And you're going to divide it by that value you got for D. And again, Web 2.0, however you want to use it. And then we're going to have a key differentiating factor here. We don't want to look at the decimals per se right now. So I get 14.28, but I'm going to give them 14 reps for right now. Okay, so I'm not going to address the 0.28. Then I'm going to find state 2. I'm going to take their population and divide it by 17.5. And you would continue this process for all 10 states by taking their population and dividing it by D. So I get 5.7 here, so they get 5 reps. So I'm going to say, okay, 5 plus 14 is 19 reps. So I have 1 left over. In the Lasa, you should have a couple left over because we're not accounting for those decimals. So when you look at explain your decision-making process for allocating the remaining seats, there's no necessarily right or wrong answer here. But what I would like to see is this decimal is 0.28. This one is 0.7. So this number state 2 is closer to 6. So I'm going to give my extra rep to state 2. And then I would need to justify that in the written portion of the report. And I would say because state 2 has 0.7, which is closer to 6, I'm giving them one of my spare reps. That's going to happen more than one time in the Lasa because you have 10 states. You're going to have a lot of extra reps. So I really want you to go back once you've given the whole number of reps. You take your leftovers and you decide who gets the leftover representation by looking at the decimals and really using that to approximate. Now, in the next part, we have to calculate the absolute and relative unfairness. So this is a formula. To do that, we have to find the average constituency. The average constituency, which it does ask us for in part 2. So to find the average constituency, we're going to take the number of the state population, so that's each state population, and we're going to divide that by the number of reps. So for state 1, my population is 250, and I gave them 14 reps. You're not using the decimal, you're using that. So their average constituency is 250 divided by 14, which is 17.85 or 17.86 rounded. The average constituency for state 2 is 100 divided by, I gave them 6 reps. So I gave them one of my extra ones. So I have to use the 6 here, which is going to be 16.67. So this is my average constituency. You would go through and follow this process for all 10 states. Take their population, divided by the number of reps that you give them. Now, this number is going to be used to find our unfairness. So I'm going to use this number to find the unfairness. And I'm just going to clear my screen a little bit so I have a little more room here. So again, my absolute unfairness is a formula. It's my larger average constituency minus my smaller average constituency. So in this case, 17.86 is larger than 16.67. So the absolute unfairness between state 1 and state 2 would be 17.86 minus 16.67, which is 1.19. Now you're going to have to continue this for every state. So state 1 to state 2, state 1 to state 3, state 1 to state 4, state 1 to state 5. I'm not going to make you go any further than that. Go all the way to state 10. So you're only looking between the states that are next to each other. That's my absolute unfairness. My relative unfairness means I take my absolute unfairness and I divide it by the smaller average constituency. So the relative unfairness of state 1 and state 2 would be 1.19 divided by my smaller constituency, which is 16.67. Again, you're going to do state 1, state 2, state 1, state 3, state 1, state 4. So we should only see 10 calculations. I'm not going to make you do the entire thing. And I would get 0.07. So that's my relative. This is my absolute unfairness. So again, this is a smaller question because I only had 2 states, but you're going to follow this process for all 10, remembering that I'm only going to find it 10 times. So I'm going to look at state 1 versus state 2. So I'm changing this a little from the directions. State 1 versus state 3. So I want you to find the average constituency, the absolute unfairness, the relative unfairness for this. State 3, average constituency, relative unfairness, absolute unfairness. State 1 versus state 4. And we're going to continue this until we get to state 1 versus state 10. So I'm just kind of limiting the number of calculations that you're doing here to make it a little bit simpler. So go back, watch this video a couple times, follow the formulas along with me with each one of your calculations, and make sure you do a really good job in that written portion of explaining how you gave the extra seats up. Now, what you need to do for the rest of your written portion is you need to explain how changing state boundaries or changing populations could affect the balance. Maybe think about the rate we learn populations are growing. Should we account for that? Should we account for changes in populations? How often should we account for them? If we change the state boundaries, would that increase or decrease the population? Should that be accounted for? Then I want you to research the Alabama paradox. I want you to research that. And I want you to cite your source and explain how and why that could occur and how it would impact giving the reps. Then I want you to research the Huntington Hill apportionment, cite your source, and explain how it helps you avoid the Alabama paradox. So this is not math. This is just doing some research and some Google. Make sure you use a reputable site, no Wikipedia. Anything .gov is good. Anything that's .edu is good. So look for a reputable source. Then, in number 7, this is your opinion. Your opinion. Is apportionment the best way to achieve fair representation? What do you think? Remember the changes in population. Remember the paradoxes. What do you think is the best way? And then maybe suggest another strategy. Maybe you've got a way you want to account for changes in population. Maybe you want to look at it every 10 years. There's no right or wrong answer to 7 and 8, but I do need to see that you did them, okay? So you can use either Excel spreadsheet or Excel 2013 to help you, or you can do the calculations by hand. You should have a nice written up report with references for where you found the information I told you to cite, and you can attach handwork, you can attach a picture of a spreadsheet, however you want to do it, as long as you've met this criteria. You can be very successful on this, Lasa. Let's finish strong.